Alright, so we are entering part 2 of our 3-part series, doing conversions using Avogadro's number. If you do not remember Avogadro's number, we looked at this when we first started looking at what a mole represents, and it was that giant number 6.02 times 10 to the 23rd of anything. It is a counting number, not that we could actually sit here and count them out, but it is a number of objects. So kind of like how a dozen represents 12 things, Avogadro's number represents 6.02 times 10 to the 23rd things, and we call it a mole. 1 mole is equal to this value. So we're going to be using that relationship, what a mole is defined as, to do this. So when we think about what this could possibly represent, if we're going to have this many of some object, it is likely it's going to be a very small object. So we're talking about things which we could generally classify as particles, but this means things like atoms. Or if you combine some atoms into a single structure that bonded together, we could be talking about molecules. Or if we have units of an ionic compound, kind of like molecules, we could be talking about formula units. So just know these are kind of like molecules. They're the same general idea, just for ionic compounds instead. So looking at our first example here, we'll dive right in. How many moles are equal to 4.01 times 10 to the 21st molecules of carbon tetrabromide? So same problem solving method. Hey, question being asked, how many moles? We want to answer this, and we have one starting number. It's a really big number, but we only have one. We have 4.08 times 10 to the 21st, and the units on that are molecules. So I'm just going to abbreviate that MOLEC. If you want to write out molecules, go ahead, but it's good to label units. And we're trying to relate this to moles. So let's take a look at that next step and think about how to do that. And the way we're going to do that is by using this relationship. We don't want molecules as a unit anymore. We want to represent this in terms of moles. So molecules is going to have to cancel. But what's good about this is we have a relationship between molecules and 1 mole's worth of something. So 1 mole, by definition, is equal to 6.02 times 10 to the 23rd molecules. So the math on this, not super hard, but can be kind of annoying. If you're comfortable using a graphing calculator and you just want to enter in these numbers as they stand with the scientific notation, go ahead. If you do not have a graphic calculator, or you may be a little less comfortable with how to use it, I can show you the general math, and we'll do that real quick with this one. So we're going to start off, you look at how this goes, molecules cancels out, we'll be left with moles. We're dividing. The ones don't really do anything. We have a number in the numerator, we have a number in the denominator. So let's just divide our initial values here. These are just, what give these numbers their values. Has nothing to do with their powers of 10, but we end up with 4.08 over 6.02, and we end up with 0.68. I'm just going to round to 2 decimal places. So 0.68. Now we have to look at our powers of 10. In our numerator, we have 10 to the 21st power. In our denominator, we have 10 to the 23rd. We have the same base. The base in both numbers is 10. So when we're dividing them, we can take their exponents and subtract. So 10 to the 21st minus 10 to the 23rd, well, 21 minus 23 gets you -2. So we end up with 0.68 times 10 to the -2. And this is the most annoying part of this. Sadly, this is not in scientific notation. I know this is kind of a lot, but we can put it in scientific notation real easily. 0.68 isn't between 1 and 10, but if we move the decimal once, 6.8 is. We've gained a power of 10 here, Well, we can't change the value of the overall number. So if I gain a power of 10 in the first part of my number, I'm going to lose a power of 10 in the second part. So we end up with 6.8 times 10 to the negative third moles of CBr4. So kind of tricky. If you have issues using a calculator to do this, let me know, but this will always work. It's just a little bit of extra work to do it. But the number makes sense. We have smaller number of molecules than what 1 mole is worth. We should get an answer smaller than 1 would do. So a little bit easier. We'll look at second example. I think this is going to be a bit friendlier to do. Try to get the hard one out of the way. So we have 1.09 moles of lithium sulfide contains how many formula units? So lithium sulfide is ionic. We're talking about formula units instead. Same kind of idea though. We have an initial number. In this case it's in moles, and we're trying to figure out how many formula units, particles this would actually be equal to. So we'll start with what we know. 1.09 moles of lithium sulfide. Put that over unitless 1. And we'll use the same number. We're trying to relate particles, in this case formula units, to moles. And we have that relationship again up top here. There are 6.02 times 10 to the 23rd formula units equal to 1 mole. So let's get units out of the way. I'm going to put moles on the bottom this time because I want it to cancel out. Best abbreviation in the class for formula units. Take the joke as you will. And so let's run this through. 1 mole is going to be equal to this many, 6.02 times 10 to the 23rd. That is the definition. Formula units. So a little bit easier. There's no division involved here. I mean, you are dividing by 1, but that isn't going to change anything. We have moles in the numerator and in the denominator, so they cancel out. We're left with formula units, which is what we're solving for. And then the math in this case, even if you don't have a calculator that can do scientific notation, is just a lot nicer. We have 1.09 times 6.02, we're multiplying in this case. And if you run that through, 1.09 times 6.02, we get 6.56. And then remember, there is still the 10 to the 23rd, which we got to include here. But 6.56 is already between 1 and 10. We don't have to change this out into scientific notation. It's already in scientific notation. And this is going to be formula units of lithium sulfide. So I got a little bit of room. I'll do the complete answer. And so this makes some sense. We have a little bit more than 1 mole's worth, so our answer is a little bit bigger than what 1 mole of anything is going to be. Additionally, when you're solving for particles, like formula units or molecules, check the exponent on this. It's really big, and it should be. Even small samples of things are a crazy large number of particles. So this is the end of part 2. We'll see you in part 3.